Today we're going to do AOPS Introduction to Algebra, problem 20.46. It says evaluate the sum of this expression here involving ceiling functions. So, in order to evaluate the sum of this, we need to find out the range for each integer. So, for example, square root 1 equals 1. For example, the ceiling function of square root 1 equals 1. The ceiling function of square root 2 also equals to 2. The ceiling function of square root 3 equals to 2. The ceiling function of square root 4 equals to 2. And the ceiling function of square root 5 equals to 3. So how do we know what to do? So firstly, we will do some casework. So for the ceiling function of square root 1, it's equal to 1. Starting from square root 2, because square root 2 is greater than 1, so square root 2 is greater than 1, less than square root 3, and square root 3 and square root 2 are both less than 2. That's just square root 4. So the ceiling function of root 2, root 3, root 4 are all 2. So there are three functions with a result of 2. So I'll just write that down. 3 times 2, and here is 1. And then let's look at what happens when we have root 5. So root 5 is clearly greater than 2 because it's greater than root 4. It's less than root 6, less than root 7, less than root 8, which is less than 3. So 3 here is just root 9. So because all this stuff is between 2 and 3, we basically have a ceiling function of 1, 2, 3, 4, 5 square roots to be 3. So we've got 5 times 3. So we do that for everything, which we're going to do now. So if we proceed on to root 10, that's greater than 3, and we have everything into root 15 and then root 16. Root 16 is basically just 4. So all the numbers in between are greater than 3 and less than or equal to 4. So basically the ceiling function for the 7 numbers here are 7 times 4. So we proceed on to numbers between 4 and 5. We have root 17, which is less than or equal to blah blah blah, until we have root 24, which is less than root 25. So root 25 is essentially just 5. It's a perfect square. So all these numbers are between 4 and 5. So we have 25 minus 17 plus 1. We have 9 numbers here. That are between 4 and 5, which have their ceiling function to be 5. So we seem to find a pattern. So if you're on the test, you can just write this whole pattern out and figure out the answer. So you have 1 times 1 plus 3 times 2 plus 5 times 3 plus 7 times 4 plus 9 times 5 plus 11 times 6 plus 12 times 7. We have to be extra careful here. We have another 8 because the equation does not end at root 49, which gives us 7. The equation ends at root 50, and root 50 gives us 8 because it's between 7 and 8. So if we evaluate this expression, we'll get 1 plus 6 plus 15 plus 28 plus 45 plus 66 plus 84 plus 8. So we have 7 plus 43. We have 7 plus 43 plus 116 plus 92. Therefore, we have 50 plus 208. Wait, so this gives us 250 plus 208, which gives us 258. So can we say this is our answer? Clearly not, because we haven't checked whether we have any mistakes yet. So let's revise our calculation here. And we indeed do have a mistake. So let's just erase this, and we can redo this part again. So 1 plus 6 is 7. 15 plus 28 is 43. 45 plus 66 is 111. 84 plus 8 is 92. But let's check the step before that. So 1 times 1 is 1. 3 times 2 is 6. 5 times 3 is 15. 7 times 4 is 28. Plus 9 times 5 is 45. 11 times 6 is 66. 12 times 7 is 84, and we have an 8. So the calculation here is correct, but still we should confirm that our pattern here is correctly found. So right now here, I'm gonna erase this part, and we should continue finding the pattern to make sure that we're not incorrect. So after 5, we have numbers between 5 and 6. So we have root 26, blah blah blah, and then until root 35, which is less than root 36. Root 36 is essentially just 6. So we have 36 minus 26 plus 1. These 11 numbers with a ceiling function of 6. Next, we move on to numbers between 6 and 7. We start from root 37, and we go all the way to root 49, because root 49 is just 7. So these 49 minus 37 plus 1, which is 13 numbers, have a ceiling function of 7. However, we still have another number, which is root 50. Root 50 is between 7 and 8, so it has a ceiling function of 8. So now if we add all these numbers up, so let me just evaluate them right here. So we have 1 and plus 6 plus 15 plus 28 plus 45 plus 66 plus 91 plus 8. So this gives us 7 plus 43 plus 111 plus 99. That gives us 50 plus 210, which is 260. So our final answer is 260. So thanks for watching. From this problem, I learned that it is important to first read the question properly so you don't mistake the ceiling function as a floor function. Then secondly, you have to always check you're working through if you have time. So thank you. I hope you learned something today about floor and ceiling functions. Bye.